Alright, well, it's good chat. So I'm gonna be making a 2D game. And if you don't know already, my game Swingy Pigeon is out on itch.io right now. If you search Swingy Pigeon, it should pop up. It looks like this. If it doesn't, this is my username right here, BigDDoruk_VR. So you can just search my username up and find this game here. And yeah, the game is really cool, so make sure to go download it. Let me just show you real quick. Damn, wait, oopsies. Wait a second, let me just install it from this page. Download. It's a very simple Flappy Bird game. Anyways, let me open up the game. Yeah, it's not a virus, by the way. It just says that all the time. Data folder not found. What? I do not understand, bro. Let me just play this version. Bro, what? Oh, okay, wait. What Sigma? Well, I don't know. I don't even know if this works, but yeah, the game's pretty cool. I don't want to go and showcase it right now. It would take too much time. Now, this guy called Brackies, I think. Yes. So he is gonna be making a 2D game. He's kind of teaching me how to make it.
Since the last video, a lot of you guys asked me how you can create some kind of score for the game. So that's what we're going to be making today when we resize our Windows.
I really want to make this game, so
So here's a step-by-step guide on getting started with your first video game. What you see on the screen now is what we're going to be making through this mini-series. It's really simple and arcadey, but it's always easy to add more gameplay elements and cooler graphics at a later point. Right now, let's just jump into it. So let's begin by installing Unity. If you've already done so, you can just skip ahead in the video. First, we need to go to unity3d.com. So you can use it even to create commercial games. The other stuff here is mostly some in the cloud features and of course the ability to customize your splash screen. So let's go ahead and hit download now. Let's also download the installer, and this should be very similar on both Windows and Mac. Go ahead and open the file you just downloaded, select yes, and then we can just skip through the installer. I'm going to choose 64-bit. If you're on a newer computer, you should.
Okay, so since it's a game about balls, we'll call it Big Balls. Because it's a game about balls, that's why. Duh.
Do the same. And this here is. That took a while. Let's hit finish. So as you can see, I'm using. We hold down Alt and left click skin for Unity. That's because I'm using it easily. So this decision here doesn't matter too much. For now, let's just keep it at 3D. Let's pick a location for our project and hit create. So here's what Unity looks like right when you open it up. You'll notice that I have a dark skin for Unity. That's because I'm using a paid version. But other than the color of the editor, that's not going to make any difference throughout these videos. So let's begin by exploring the user interface. So in the middle here, we have this scene view. You can use the mouse wheel to zoom in and out. You can use the middle mouse button to pan around. And if we hold down Alt and left click, we can then pivot around the center of our view. Over here, we have the hierarchy. This displays all of the different game objects that we have in our scene. You can see here our scene is currently untitled and it has two game objects, the main camera and the directional light. Notice that when I click on an object, say the main camera, the inspector will display properties for that object. Each one of these collapsible things here are called components. Components are what makes objects do different things. but we'll get into that in a second. We also have the project panel down here, which shows all of our different game assets that we can then drag into our scene, making them appear in the hierarchy. You can totally rearrange Unity in any way that you would like and drag around panels and really go crazy with this, but remember you can always go to the top right corner and select default, and it's going to reopen to the default layout. And any window you don't already have open, you can go to window and select it from here. So let's start building our game. First off, we want to create a ground plane for our player to stand on. To do that, let's go over to the hierarchy, right click, you can also go under create and select 3D object cube. This spawns a new cube into our scene. Again, we can use the movement controls to have a look at it, and we can always quickly focus on it by hovering over the scene view, selecting it and hitting F. Now the cube currently is somewhere in our scene and it's really hard to get a look at where. So what we'll do is just go over to the transform here, right click and hit reset. And that just centers it.
I know how I can play the game. Downloads. Yeah, bro, I don't know.
You can see the position is now 0 on the X, 0 on the Y, and 0 on the Z, and gives it a scale of 1 by 1 by 1. Again, hit F to focus on it. So if we go into our game view, we can now see our cube through our camera. If we want, we can take our game view here and dock it to the right so that we can see both our scene and the game view at the same time. Then we can take our camera here and we can readjust its position, and you can see that updating in real time. I'm just going to press Ctrl Z to undo that. I'm then going to select the cube and scale it up. Let's give it a scale of 15 on the X. We keep it at 1 on the Y and give it say 100 on the Z. If we zoom out now, we can see just how huge this ground plane is. We can then go and rename it to ground. And we can simply drag on the blue arrow here to move it over. Something like that, just so it starts about at the same point as our camera. Then let's create another object, so right click, go 3D object and then cube. Again, let's reset the transform so it's centered on our scene. We can then drag on this green arrow to move it up. Let's again hit F to focus on it, and we can see that we now have our new cube here standing on the ground. This cube is going to be our player, so let's go ahead and rename him to player, and let's also make him a bit more visible, because right now everything is pretty boring white. To do that, we need to assign a material to our player, and we create a new material in the project panel. So let's right click down here, go create, and then material. We'll name this material our player and then mat for material, but that's optional. Let's hit enter. Now we can adjust different properties on this material, stuff like how metallic it should be, the smoothness of the material, and the color up here. So we'll make this some kind of bright red, and what we can do is then simply drag our player mat onto our cube, and you can see it updating in real time. We'll simply let go and it's applied, and any changes that we now make to this material are going to update for our player. I think our camera is a bit far away, so let's also select our camera and move it a bit closer. Again, we can move it over by simply dragging on this arrow, move it up a little bit, and that looks a lot better. So now if we were to hit play and actually run our game, not much happens. That's mostly because we haven't done any programming yet, and so we can't really control the player, but we also need to add some physics into our game. Right now, if we exit play mode, take our player, drag him up here, and hit play again, he's just going to float in the air. He's not falling down. The reason why is that we need to tell this game object to interact with the Unity physics system. To do that, we go out of play mode and add a new component. In our case, we want to add the physics rigid body component. Now when we hit play, we should see that our cube falls to the ground, and indeed.
Alright, let me just do all that real quick. Yeah, this guy took a lot of time to explain really simple stuff. But that's good, I'm not complaining. That just kind of makes it better for beginners, I guess. Yeah, that's nice. And then 3D object, cube, player. Let's see. Great.
It does. Right now it falls in a bit boring way, so let's try and rotate our cube a bit to make it more interesting. To do that, we switch to the rotation tool. Notice how all of the different tools are up here. Right now we have the move tool selected. We can also shift to rotation, scale, and then this one is for manipulating 2D graphics, which allows you to easily do all of the different things at the same time. You can always switch between these really quickly by using Q, W, E, R, and T. So we're going to press E to rotate, and I'm just going to kind of rotate it in a random way here. So if we now hit play, he's going to fall down, and we can now see that he has a lot more advanced physics applied than we were able to see before. So I'm just going to undo that rotation by pressing Ctrl Z, and I'm also going to move him down here. We can also try duplicating him. So let's press Ctrl D to duplicate, and let's move this one up and over a bit and see how they interact with each other. Awesome. So one really important thing to understand is what is making these objects behave this way. And the answer is, of course, components. So if we now exit out of play mode and select the player here, we can see that he has all of these different components. The first one is something that you will see on all game objects called the transform component, which just keeps track of where the game object is in space, how it's rotated, and its size. You can see we can adjust all of these, and the game object will be adjusted accordingly. And also, if we go ahead and drag on the game object, you will see the transform component updating. The rest of them, though, are all optional. We have the mesh renderer down here, which is responsible for drawing the object on the screen. If we go ahead and disable that, it's actually going to disappear. It's still in here, you can see it's still in the hierarchy, and it still has this green box and we can move it around, but until we re-enable the mesh renderer, it's not going to be visible. Then of course we have the box collider. Without this, we wouldn't be able to collide with other objects. If I go ahead and disable the box collider and then hit play, this should just fall through the ground. But if we then go ahead and re-enable the box collider, you can see that it's now able to collide with everything. So remember, to get realistic physics, we both need a collider and a rigid body, and in order to see it, we need a mesh renderer. I of course skipped the mesh filter up here. That's not because it's super advanced, it's just that this is only responsible for a very simple thing, and that is choosing the shape of our object. Right now you can see it has the cube selected. We can easily go in here and change it, so we simply click on the little ball here, and we can change it to a capsule, a cylinder, a plane, a sphere. That it has a sphere collider, so if we go ahead and hit play, it acts like a sphere, and this is of course more noticeable if we move it over so that we can see it hitting the box, and it's going to go and roll off our ground plane. Another thing is you can also adjust values while playing. We could take our player here and we're still playing and move him around as you quit playing. So make sure not to do any important adjustments while playing, or at least remember your settings, or else you're just going to have lost progress. So the final thing I wanted to do is just delete the ball here and maybe make this a bit prettier by changing our skybox. To do that, we go and select our main camera, and as the skybox here, we're going to change it to solid color, and let's make the color here a very white gray. Not the most exciting thing in the world, but I think it looks pretty simplistic and cool. By the way I just maximized the game view here is something you're going to see me do a lot of times. That's by hitting Shift Space. Finally, to save your game, we can go ahead and hit Ctrl S or Command S if you're on the Mac, or go to File. Game view here is something you're going to see me do a lot of times. That's by hitting Shift Space. Finally,
I went to the main camera and then did skybox. Oh, okay. Yo, just tell me that doesn't look fire. Tell me that doesn't look fire, man. Tell me that doesn't look fire.
To save your game, we can go ahead and hit Ctrl S or Command S if you're on the Mac, or go to File, Save Scenes. Then we need to name our scene something, and scenes in Unity are basically just levels. So we'll just go ahead and call this one Level 1 and hit Save. You can see now that the scene appears down here in the project panel. If we had multiple scenes, we would be able to shift between them by simply double clicking to load that level up. So that was pretty much all of the handy tips that I could fit into this video. I know some things are probably really confusing, but really the best way for you.
Easy.
Today we'll get started programming in Unity. I did a poll asking what language you guys would like to see, and the results were, well, conclusive. So today we'll be creating our first script. We'll have a look at how you can change properties and even add forces to an object. So I'm really excited. Let's just jump right into it. So whenever we want to program in Unity, we create what is called a script. To do this, we click on the object that we wanted to sit on, in our case the player, and we hit Add Component, Then we go down here, select new script, and we can give a name to our script. In our case, it's going to be something like player movement, but you can really choose anything you'd like. And we select the language. In our case, that's going to be C#. So create an add, and you can see that Unity adds a new component. And that's because scripts in Unity are pretty much just custom components that we get to tell what to do. It's also created a script file down here in the project panel, and that means that we can add it to other objects as well. So if we now select our ground, we can drag our player movement onto that in order to make it affect the ground as well. But we don't want to do that, so let's just right click on it and hit remove component. So if we go back to our player and double click on our player movement script, it's going to open up in your script editor. If you're on Windows, that's either going to be Visual Studio, which is what I'm using, or MonoDevelop, which is also what you're going to be using on the Mac. It's really up to personal preference, and you're going to be able to follow along just fine with either. So this is what a script looks like just when we create it. There's a lot of scary stuff going on here. The thing about learning to program is that at first you're just going to have to ignore most of the stuff that's going on. To clean it up a little bit, we can go ahead and delete the two using tags up here, and really the only thing that you should focus on right now is these two functions where it says void start and void update, and these are created by Unity automatically. So let's have a look at the start function up here. The neat thing about the start function is that it will run when your game starts. That means that whatever code you put between this curly bracket and this curly bracket, so that means in here, is going to be executed when you start the game. Do note that in C#, it doesn't matter how many spaces you have. You can really space it out any way you want. You can even put it on separate lines as long as you don't split up a word like this. Let's just try and see if this is working by displaying a message to ourselves. To do that, we write debug.log and make sure to have capital letters the same places that I do, because C# is cap sensitive. Then we open up a parentheses and you can see that it automatically closes one as well. Then in quotation marks we get to write a message. In our case, we'll just write something like hello world. Make sure you end this line with a semicolon. You're going to be doing that a lot. Whenever you write a command, you're going to end it with a semicolon. If we now save this by hitting Ctrl S, you can see that it saves up here. Hit back into Unity and hit play. Nothing is really going to happen in our game view. However, if we go ahead and look at the console here, you can see that it now says hello world. If you don't already have the console open, you can go window and then console. So the console here is used by us to debug our code. It allows us to write messages by using debug.log followed by our message, and it also displays warnings and errors about the code that we write. So we really have a love-hate relationship to the console. If something isn't working in your game, make sure to check the console and see if there's any errors or warnings. They might help you troubleshoot the problem. Alright, so writing hello world in the console is a bit boring. Let's have a look at what else we can do. Well, in fact, we can do pretty much anything in Unity. We can modify values, we can add forces to objects, we can add explosions, create game timers and menus. The possibilities are pretty much endless. And that's also kind of what makes programming scary, is that you have a lot of functionality available to you. But let's try and focus on a specific problem. So let's say that we want to go into our rigid body and disable gravity for that object. To do that, we need first of all to reference this rigid body component, and Unity makes that really easy. If we go into our script and go above our functions on this empty space here, create some new lines, and then write public, then the name of our component.
Buddy.
Above our functions on this empty space here, create some new lines, and then write public. Then the name of our component is called rigid body. Then the name of the component that we want to modify.
So, so public. Perfect.
In our case, rigid body. And now we need to give this reference a name that we'll use internally. So we can call it something like RB for rigid body. If we save that and hit back.
Just do public rigid body DRB.
Back into Unity, we should now see an empty slot here with the name of RB. We can then take our rigid body and drag it into that slot. So now whenever we write RB in our script, it's going to refer to this particular rigid body. That means that if we go back into Visual Studio and instead of writing debug.log here, write something like rb.use gravity, we can set that equal to either true or false. In our case, we're going to set it to false, and then of course end with a semicolon. So save that, let's hit in a Unity, and let's see.
Calm down.
Set it to false.
Calm down. Ah. Alright, so rb.use gravity equals false. Semicolon. So let me just summarize real quick. Public rigid body RB. That made a section in the script which let me put a rigid body in there. So doing public makes that a thing, I assume. Rigid body makes it so that I can only drag a rigid body in there. And RB is just what it's gonna say. So RB and then none rigid body. Okay, perfect. RB.use gravity equals false. Rigid body uses gravity as false, so it won't comply with gravity, I guess. I'm not quite sure what that's gonna do yet, but we'll see.
And then of course end with a semicolon. So save that, let's hit Inner Unity, and let's see if this value isn't going to change when we hit play. So let's hit play, and indeed the use gravity changes.
Oh, okay, perfect. So, okay, now I understand. RB.use gravity. So by RB, because this is RB, and it knows that this is the rigid body of it. So now it's gonna automatically do a reference to this rigid body. So use gravity. It's talking about this action here. And when it's equal to false, it will be false when the game starts. So the cube won't fall down. Let's test. Let me see. Uh-oh, it just put me out of play mode. Yup, doesn't fall down. Perfect. Great, I understand.
To false. We can see that our cube here is hovering in the air, and if we were to duplicate him so that the two would collide, you can see just how cool of an effect that already gives us. But this is just editing a tiny little property. We can also make our rigid body do different things. If we quit playing, go back into Visual Studio, we can actually add a force to that rigid body. So instead of writing rb.useGravity, let's write rb.add force. And again, we open a parentheses, close a parentheses, and then
rb.add force, which should mean that there's an add force thing here. Or no, or there isn't, and that's just the action during scripting. Okay. So, or it could be, but I don't see it. I don't know. So rb.add force semicolon.
end with a semicolon. However, you can currently see that this is displaying red. And the reason why is that we need to specify a few things. These are called function arguments. The add force method wants to know how much force it should add in the different directions. So we could start with 0 on the x-axis. We could do something like 200 on the y and maybe 500 on.
Okay. So RB, so the rigid body that we put in the slot rigid body, will add force. And then in the brackets is the force that it's gonna add. So you have to write the y, the x, and the z. So yeah.
On the z. Notice how I separate each number with a comma.
X,
we can then
y,
hit save,
yeah,
go back into Unity, and when
I said it wrong.
we now play, we should see a force being applied to this object.
Ooh, let me see that. Yeah, I actually really understand this now. Yes, and then it like flips over. Physics.
Awesome. So let's stop playing, head back into Visual Studio, and what we want to do is not only add a force in the beginning of the game, we want to add a constant force in order to move our object forward. To do that, we can't use the start method. Remember, this is only called once right when we start the game. However, our update function is called once per frame. That means that whenever the computer draws a new image, and it does this multiple times a second, this function is going to run. So let's again put this on a new line to make things a bit easier to see, and we can then write rb.add force, just like we did up here. We can input 0 on the x, 0 on the y, and let's try 200 on the.
Okay, so here, what it's gonna do is RB, again, the thing that we put in there for RB, add force, the same action, so it's gonna add force, and then like again like before. But when we do it in update instead of start, see, if we do it in start, it happens when the game starts. If we do it in update, it's updated every frame, so once per frame. So 0, 0, 200 now. We'll do a semicolon, and this should add force to the cube every second, like non-stop.
The Z. Again, remember to close it with a semicolon. Let's also take our entire start function up here and remove it. So now we...
Ooh, okay. Okay, so now, he's doing something else. Now, he's deleting this whole part, so nothing will happen on start. And this will just happen every second.
We hit save, go back into Unity, hit play, and we should see our cube just launching into the distance.
Yup, let me see. I mean, that's what I assumed will happen. But let's see if it actually happens. So, yes, perfect. So good.
And indeed we do. However, even though our game currently runs just fine and we get no errors in the console, we do actually have an error in our code. If we stop playing, head back into Visual Studio, we can see that everything looks just fine. But there's one problem. And that is, if this method is called once per frame and we add a fixed amount of force each frame, how much force we add over a second is actually going to totally depend on our frame rate. And that means if you have a really good computer that is drawing a bunch...
So then, your luck and skill will be dependent on your computer. Yeah.
Bunch of frames a second, the cube is going to travel faster than on a slower computer that doesn't run as many frames per second. And the frame rate can even vary on the same computer. If a bunch of stuff is going on the screen, the computer usually slows down a bit in order to handle everything. Or if something is happening in the background, that might also change your frame rate. So in order to even out these differences, what we do is we multiply this value, the 200 here, with what is called time.delta time. This is a bit confusing, but basically what time.delta time is the amount of seconds since the computer drew the last frame.
Ooh. Okay. Perfect. Alright. So now basically what would happen is, now that we have add force, instead of like updating it every frame, which would depend on your computer, now it's going to do the 200 times time.delta time, so the amount of time before it last happened. So let's say I want it to happen 0.1 seconds before the last time it happened. No matter how good your computer is or how bad it is, every 0.1 second it would get a new notification and move. Yeah.
So if the update is running 10 times a second, this value is going to be 0.1. And if it's running 20 times a second, this value is going to be 0.05. So the higher the frame rate, the lower this value is going to get. And therefore it's going to even out the advantage that you would get if you were running on a good computer. If you don't get this right away, that's totally understandable. I sure didn't the first time, just right after me for now. So if we now save this and go back into Unity, we should actually see a pretty big difference. And that is, our cube is not moving now at all. And that's because on my system, it's drawing a lot of frames, and so overall the value gets a lot smaller than it was before. The workaround for this is super...
Oh, let me see mine. Does mine move? I guess it depends on your PC then, how fast. Or, no. Nah. It's barely moving. It's hard to tell. I mean, it's basically impossible to tell.
Super simple. We just need to go into our script and make this value bigger. I'm just gonna add another 0. Save that, go into Unity, hit play, and we should see him just storming off here. It doesn't look like...
Great. Okay, that's because that was a small value. And it was actually moving, but really slowly, and we couldn't really tell. So now that it's 2000, it should move way faster. There we go. The physics are making it kind of just go like that and fly off the edge. Now what we do?
Like much of a difference, but now we could at least know that it looks the same way on all systems. The final thing we're going to do is yet another one of those, it doesn't look like it's wrong, but it's actually a little wrong kind of things. And that is that Unity really likes it if we use what is called fixed update instead of update for calculating physics. And in our case, we are using the Unity physics system. So just make sure that whenever you do physics stuff, if you're adding forces or changing velocity, do it inside the fixed update. Unity likes that a lot better, and it's going to make everything look a lot smoother when you collide with stuff. Also, if you find all of this confusing, I totally get it. One thing that you can do is use the fact that we can make comments inside of our code. So you can see this line here is grayed out. That's because it's marked with these 2 slashes. Whenever you create 2 slashes and follow it up with some text, that text is not going to be included in your code. And so it allows you to say stuff.
Hmm? Right.
Like
I have
this.
to go eat dinner in a bit.
So just go through your code and add some comments to help you out. You can even add comments at the end of a line. Also, I see a lot of beginners using spaces to indent their code. I find it a lot easier to just use tab, but it's something programmers have argued about for decades. So let's just save our code a final time and enjoy the result. Until the next video, you can of course play around with this by adding more objects into the game. Let's add another cube here, for example. And this already has a box collider, so it should actually collide. That's pretty much it for this video. I hope you liked it. If you did, hello everyone! In this video, we'll make our player move. To do that, we'll have a look at variables, if statements, and player input. So if you want to make games in Unity, this video is pretty much essential. I'm ready. Are you ready? Let's go. Before we get started, I just want to mention that you can now download the project files and the scripts from each video over at DevAssets. So if we go to devassets.com, this is a website I created where you can download really high quality 3D models such as this Western props pack. We have a modern weapons bundle, some cool looking sci-fi vehicles, and a lot more. If we go to browse, scroll down to the bottom here and click how to make a game, we get to this page where you can download all of this stuff. I've seen a lot of tutorial makers make their project files paid, but I don't really think that's fair to you guys. Instead, as with everything on the site here, I've made it pay what you want, so you can of course go ahead and grab it for free or choose to support me with some amount. You can just click the one that you can afford here and then hit the blue button and you're good to go. So back to the video. In the last one we made our cube fly forward by adding a force. Right now our primary issue with this is that our player doesn't stay on the ground. He just starts rotating and jumping and goes crazy. One way to fix this is to go to the player, find the rigid body and add some constraints. We could for example freeze the rotation on the x-axis, and that should result in smooth movement. However, we do want our cube to be able to rotate so that when he collides with something, it's going to look cool. So let's uncheck that, and instead let's create a physics material. The reason for the cube jumping around is that by default there's friction between the cube and the ground. By using a physics material, we can choose how much friction we want. So let's right click in the project, go create, and then select physics material. We can rename this to something like slippery, and we can set both the dynamic and the static friction to 0. Then we can drag this onto our ground, and you can't see it being applied, but if we go ahead and select our ground, we can see that the material under the box collider is now set to slippery. And that means that if we hit play now, there's no friction between the cube and...
Oh, let me see that. Alright, perfect. So I'm really happy this tutorial still works, even though it was like 8 years ago. But yeah, I'm gonna go eat dinner now. Ooh, and then I gotta shower anyways. But I'll probably still have time to work on this game. I really want to make this a great game. And I also want to learn how to script basically in the process. But yeah, anyways, thanks for watching the stream. Make sure to come back for day 2. Well, it is still day 2, so make sure to come back for day 2 again. And then tomorrow I'll stream again, but it will be day 3. So yeah, thanks for watching the stream.